Hello my dear students, welcome back to NEET World. So this is our session on IPE class 11th chemistry part, okay, and in this session we'll be discussing stoichiometry 2 marks questions. I hope you know that there will be one question we can expect for 2 marks from this stoichiometry point of view right now. So before that, see, so before that, I just wanted to announce about our C60 material. See, this is our C60 material designed to score 60 out of 60 in your IPE exams. Whether you can be from Telangana or AP states, or whether you can be from first year or second year of your intermediate. Okay. So for both students, we will be providing this free C60 material, not only chemistry but also for physics and mathematics and biology for BPC students. Okay. Now you can access this material for free of cost from MedWorld app. So what do you need to do? So just go to Play Store. Okay, just go to Play Store and then next get your a MedWorld app from the Play Store. Download this MedWorld app. Okay, so then next after getting log into this MedWorld app, just go to chart section and mention just hi, or otherwise you mention your class number. For example, if you are class 11th student, so class 11th IPE material, you just ask them in the chart box. Okay, then our team will guide you how to access this free study material and to make your preparation more effective and more productive. Okay, so you can also share this with those students who are preparing for IPE, like your friends, your juniors, your seniors, whoever it is preparing for. Okay, then next, right, so in this material, see, if you open the material, so it will be like this. Yeah, these are the chapters, and you know, here we have provided blueprint also, chapter wise weightage, everything is mentioned. Yeah, so now we will be discussing stoichiometry. Yeah, from here you can expect one 2 marks question and one 4 marks question in the final exam right now. So already I have explained most of the 4 marks VSAQ questions from all other topics. So let us see this very short answer type question from stoichiometry first. Okay, right. So look at this first. Yeah, so here is our chapter here, stoichiometry. So what is the first question says here? Just read it once. What is a redox concept? And give one example. This is the first question they are asking, right? Yeah, so just tell me what you got from here, from the topic name itself. So what is the first question says here? Just read it once. What is a redox concept? And give one right. So everything is clear, voice, video, audio, everything is clear now, right? So let us start our discussion. So what is a redox concept? Give an example for this. So the term redox means the reactions in which both oxidation and reduction part is involving. Okay, so here you can see the term redox means a reaction in which oxidation as well as a reduction occurs simultaneously. Now what do we mean by oxidation? Yeah, so here you can say oxidation means loss of electrons or addition of oxygen. Okay, so oxidation, it means we are adding oxygen. See, to this zinc, now what if we add any oxygen, then we can say it is an oxidation process. Or the other way of defining oxidation is removal of electrons is also called as oxidation. So just look at here. Here we have zinc metallic form here in zero oxidation state. So just see here what I am writing, Zn plus CuSO4. Okay, so now what is the oxidation state of zinc here? 0. And in this sulfate, copper sulfate, copper is in +2 oxidation state. Now what happening here? So zinc is converting into Zn plus 2. It means 0 is converted into +2. It means what is happening? See, if we remove 2 electrons from zinc atom, it will become zinc ion, like Zn plus 2 ion. Okay, and whatever the electrons we have removed, that will be taken by this copper from this copper sulfate solution. Okay, it will become copper here, and our zinc +2 ion and this sulfate ion forms ZnSO4 solution. Okay, so this is what taking place here, happening here. So now what is happening to zinc? Zinc is losing the electrons now, so you can say this process as oxidation process. What is this? Oxidation process. Whereas copper +2 ion is gaining electrons to converting into copper, so it is gaining electrons now. See, gain of electrons is called a reduction, so this is called reduction. Okay, you got, I hope. So what do we mean by oxidation? Loss of electrons is oxidation and gain of electrons is reduction. So this is what happening here now. So in the one reaction itself, both oxidation reaction taking simultaneously, right? So we can say this reaction as a redox reaction. What we can say? It's a redox reaction. Okay, so here zinc is oxidized to Zn+2, whereas copper plus 2 is reduced to copper. Okay, loss of electrons in oxidation, gain of electrons in reduction. That's it. So this is how you need to present your first question, that is what is the meaning of a redox reaction with 1 or 2 examples, means yeah, like this you need to mention. Okay, the next, what is a disproportionation reaction? Okay, give one example for this. This is a second question asking from stoichiometry. So what you can say, so disproportionation reaction means there are some redox reactions in which same element will undergo oxidation and reduction simultaneously. See here what is the thing they are saying, when the same element undergoes oxidation and reduction simultaneously in a single step, it is called as disproportionation reaction. So what is happening, same element will undergoing both oxidation and reduction, then we can say that as a redox, disproportionation reaction. Okay, so look at here, I have copper plus 2 ion. See what I am writing, a simple example I am writing here. Just see what I am writing. Yeah, so copper plus 1 ion I have. So now this will be getting reduced to copper metallic state. Okay, and the next here copper plus 2 ion. So what is happening, see plus 1 is converted into 0. It means by gaining 1 electron it is becoming atomic form right now. So this process, gain of electron, is called reduction. What you can say, reduction. And from plus 1 to plus 2, what is happening here, losing 1 electron now. So minus 1 electron, losing 1 electron, you can say it as oxidation. Okay, gain of electron, like gain of electron, loss of electron. So both is happening for the same species now. So same element undergoing reduction and undergoing oxidation. So you can say this as a disproportionation reaction. Okay, what is that? Disproportionation reaction. So this is an example of redox reaction only, but in that further classification particularly we say it as a disproportionation reaction. If same element undergoing both reduction, oxidation, then that redox reaction is called as disproportionation reaction. Okay, hope the discussion is clear up to here. The next, so in this type of reaction, element is present in an intermediate oxidation state, right? See, copper can exist in plus 1 oxidation state, okay, or it can be 0, it can be plus 1, and it can be plus 2. These are the 3 most seen oxidation states for copper. So if you see at this reactant side, it is in intermediate oxidation state like plus 1. Okay, now it can undergo to maximum oxidation state plus 2 or minimum oxidation state 0. So you can see in this type of reaction, element is present in intermediate oxidation state and changes partly to a higher and partly to a lower oxidation state. Then those reactions are considered to be disproportionation reactions. Hope this is clear now. Right. Let us see one more example here. Here I have mentioned peroxide, hydrogen peroxide. See, H2O2, what is happening, just see, there are 2 oxygen atoms here. See, here I am taking, now what it will be converting into is H2O plus O2. Now what you are seeing here, see, here oxygen is in minus 1 oxidation state, converting into minus 2. Okay, number is reduced now, number is decreased now from minus 1 to minus 2. Yeah, so this process you can say it as a reduction. What you can say? Reduction. And from minus 1 to 0 here, whenever a species is combining with itself, oxygen is existing within itself right now, so the oxidation state will be 0. So minus 1 is converting into 0 means this is what process, by losing the electron it is happening now, so it is oxidation. Okay, like this you need to identify reduction, oxidation, that is from same element, then we can say it as a disproportionation reaction. Okay, right. So yeah, second example also clear. The next, see, third, one more example here I have mentioned in the book. So just see here, P4, it means phosphorus is combining with itself, therefore its oxidation state is considered to be 0. Now in basic medium it will undergo a disproportionation reaction. Then what it will form? It will form PH3, pass spin it will be forming, along with the pass spin it will be forming H2 PO2 minus, H2 PO2 minus. So what it is, see this is a pass spin, -3 oxidation state here and here +1 oxidation state. So from here to here it is undergoing reduction, 0 is converting into -3, reduced in a number is reduced in a 0 to minus means it is reduced by gaining of electrons. Okay, whenever a species gains electron, that number present on it will be reduced. Okay, if it is having +1, by gaining 1 electron it will become 0. If it is gaining 2 electrons, the +1 become -1. Okay, if it is gaining 3 electrons it becomes -2. Like that, number of electrons as it gains, that many numbers get decreases. Okay, so here 0 is converting into -3 means by gaining 3 electrons by 1 phosphorus it is forming -3 oxidation state here. Okay, now when it comes to this 0 to +1, it means this phosphorus is losing 1 electron in the formation of this product. So same element undergoing reduction and undergoing oxidation. So I can say this reaction as a disproportionation reaction. What we can say, this reaction is the best example of disproportionation reaction. Right. Hi, good afternoon. In the chat box, yeah, so just tell me, is this clear whatever we are discussing in the class? Right, it is clear, right? So now one more reaction we have similar to this but opposite of this. What I am saying, opposite of this disproportionation reaction can be considered to be comproportionation reaction. Now tell me what is happening in comproportionation reaction. I told you opposite now. Yeah, so try to get something from that opposite word here. What is happening? Try to understand a disproportionation reaction once again from our discussion. Yeah, so see here, what are comproportionation reaction? Give examples. See here what they are saying, when two species of same element in different oxidation states react to form a compound in which the element attains an intermediate oxidation state, okay, then the reaction is called as a comproportionation reaction. See, let me tell you or let me show you once. So look at here in the given example, if you observe, silver like Ag can be in +2 oxidation state. Okay, this is maximum oxidation state, and it can be atomic form also, 0 oxidation state. Okay, now it will be converting into Ag plus. So now what you are seeing here, so one Ag is in +2, one Ag in 0 and converting into Ag plus. So what is happening, this fellow is losing the electron and this is gaining the electron. So the same element, see, having different oxidation state for the reactant side, converting into product form which is having same oxidation state. Okay, so now this is something like reverse of disproportionation. Now in disproportionation reaction what we have studied, one oxidation state will undergo both oxidation and reduction. That is what we have seen in the disproportionation. See, the different oxidation state, higher one, lower one, forming an intermediate oxidation state containing species here. So these kind of reactions are considered to be disproportionation reaction. So read this statement, when two species, these two species of same element having different oxidation state, yes, having different oxidation state, react to form a single oxidation state containing compound, yes, single oxidation state containing compound which is an intermediate oxidation state between these two individual oxidation states. Right now, then you can say this reaction is a best example of comproportionation reaction. So look at here, here also copper +2 and 0 converting into copper +1. So that is also an example of disproportionation reaction. Okay, right. That is also an example of comproportionation reaction. Okay, hope the discussion is clear. Right. Next one is calculate the oxidation states of manganese in these 4 compounds. So it's very easy. Guys, whatever I'm mentioning here in the discussion, all of them are asked previously in the exams. Okay, so just follow them whatever we are discussing here. So first one is KMnO4 we have. So how do you write the oxidation state of manganese here? See, you can write KMnO4. Okay, so the oxidation state of manganese they are asking. So let us say the oxidation state of manganese as X, and how many potassium ions are there? One potassium is there. And what is the charge present on potassium? See, all alkali metals where they can combine with anything. What I am saying, alkali metals combining with anything, they will always be having +1 oxidation state. Okay, because alkali metals are highly electropositive when we compare with the other metals, that's why other elements. So that's why the alkali metals will be are of unipositive charges, unipositive species, okay, in their combined states. Okay, so 1 into +1, okay, because one potassium is there, 1 into +1. Okay, manganese, let us say X oxidation state, and we know oxygen is more electronegative than other these two elements, and each oxygen, there are 4 oxygens. Okay, each oxygen will be in oxide form -2, so you can take here -2 oxidation state. Overall molecule is neutral, so equal it to neutral, 0. Okay, then what happens, this is +1, this is -8, so it becomes -7. If you send this side, it will become +7. That's it. This is how you need to calculate the oxidation states of each of these elements here in this given compounds. Okay, right, is this clear? Is this clear or not? I hope it is clear. Similar way, you just do it for K2MnO4. Please do it for K2MnO4. See, there are 2 potassiums are there, so 2 into +1 for each, and there is manganese, consider X. There are 4 oxygens, each oxygen is -2. Overall charge is neutral, because compound is neutral, no? So overall charge will be neutral. Now what happens, tell me, this is 2, this is X, this is -8 equals to 0. So from here what you can say, X will be minus, here it is -6, 2 minus 8 is -6. Send this side, it will become +6, that's it. So X will be +6. So this is how you need to find their oxidation states. Okay, so in the same way, if you calculate for this ion, okay, manganate ion, okay, this is called manganate ion. Okay, see, this is called potassium manganate, this is potassium permanganate, this is just a manganate ion. So if I say permanganate ion, so from here you need to take only MnO4, you need to take MnO4 minus. Okay, so this is what permanganate ion, and because this is potassium permanganate, then this is permanganate ion, this is manganate. From that, if I remove this 2 potassium, you should say manganate ion. Okay, so in this manganate ion, you have manganese, oxygens, and -2 charge. For manganese, consider X is the oxidation state. There is 4 oxygen atoms, each one is -2 charge. Overall charge present on it will be -2. Like this you need to take. So the next X becomes what? -2 plus 8. This will be +6. This is the oxidation state of manganese in this manganate ion. Okay, so here it is +6. So everything is clearly mentioned here in our book. Okay, so what do you need to do? Just go to Play Store, download MedWorld app, then access this free study material, and you can get all this access. Okay, right. The next question here says, calculate the oxidation states of oxygen in O2F2 and OF2. Okay, it is also very easy, right? So the same steps that we have followed previously, do here also. See, oxidation states are given based on the electronegativity difference between the attached atoms. Okay, let me explain here once again. See, O2F2 is given. How do you write this? O2F2 means, see, they are asking calculate the oxidation state of oxygen, this oxygen in O2F2, between oxygen and fluorine, which is more electronegative? We know fluorine is more electronegative. If fluorine is more electronegative, whatever the bonded atoms, bonded electrons are there, those are moving, or those are polarized towards more electronegative atom only. So we know fluorine is more electronegative, the bond will be taken by fluorine only. Here also bond will be taken by fluorine only. So the bonded electrons are moving with fluorine, means what happens now? Oxygen is losing its, like this, one electron of the oxygen itself taken by fluorine. Therefore fluorine becomes fluoride ion and oxygen becomes O minus, okay, O plus here. Why O plus? Because electrons are taken by fluorine only, na, that's why it is becoming fluoride, okay. So here the bond remains same, here also +1 and fluorine is in -1 oxidation state, that is fluoride. So the each oxygen in O2 F2 is with what charges? +1 charges, okay. Now if you wanted to calculate in the mathematical way, right, take it like this. So out of these two, there is 2 oxygen atoms. Each oxygen atom is having oxidation state X, okay, and there are 2 fluorine atoms. Each fluorine is -1 oxidation state, okay, and overall molecule is neutral, so equal it to 0, okay. Then now what happens, tell me? So the 2x -2, if you send -2 to that side, it will become +2, okay. Then 2 cancel, so x will be +1, okay. Now what is the oxidation state of each oxygen we got here? +1. So in the same way you can get it from mathematical forms or from this bond explanation also, okay. Yeah, so is this clear now? The oxidation state of oxygen in this O2 F2 is a +1, okay, right. In the same way, can you calculate it for oxygen difluoride? Oxygen difluoride means what? OF2 here. So OF2, just write the structure of OF2. First of all, see, you can directly use mathematical form also. I wanted to give you some clarity, conceptual clarity, that's it, okay. See, OF2 is there like this. So which is more electronegative, tell me? Fluorine is more electronegative now. So the bonded electrons are taken by fluorines, means this bond taken by fluorine, it becomes fluoride, okay. So then with respect to this bond, oxygen will get positive charge, and similar way this with respect to this bond also, fluorine will get -1 charge, oxygen will get +1 charge. Therefore what is the net charge present on oxygen? +2. This is what you need to know here, okay. And if you wanted to do it in the calculation mathematical manner, so just take here for oxygen as X, and there are 2 fluorines, each fluorine is in -1 oxidation state, overall molecule OF2 is a neutral, so equalize it to 0. So then X will be equals to -2, if you send that side becomes a +2. So this is how you need to calculate the oxidation states of any species in the given compound, okay, right, okay. So is this clear? Whatever the questions mentioned in the book is discussed here, okay. The next one is the empirical formula of a compound is a CH2O, okay. CH2O is a empirical formula. Then molecular weight is 90. Calculate the molecular formula. So what do we mean by empirical formula, molecular formula? First of all, you need to understand the basic difference between empirical formula, molecular formula. Once after understanding them, then you can calculate these questions easy. See, empirical formula is the simplest whole number ratio of elements in a compound, while molecular formula gives exact or actual number of ratio of elements. For example, see what I am writing here. So try to understand the concept here. Very easy and important to be understood here. See what I am writing. I am writing C6H12O6. This is a general formula we will be writing for glucose right now. So this is the formula, molecular formula of glucose. This is molecular formula. MF I am writing, molecular formula, okay. So now this molecular formula, whatever I have written here, it clearly says number of carbon atoms, hydrogen atoms, oxygen atoms present in this one molecule of glucose right now. So but if I write its empirical formula, so now what happens, tell me? So empirical formula is nothing but the simplest whole number ratio of this species. How many carbons are there? 6, 12 hydrogens, 6 oxygens. So now what I am doing is I am writing C1H2O1 and taking 6 number outside. So now what is the resulting species here we got here? CH2O. So now how this CH2O is looking? So we don't know whether CH2O belongs to which type of molecule it is, okay. So there are many molecules fits with the same empirical formula, but molecular formula will be mostly, it will be unique for different molecules, okay. So let me give you one more example. I will be writing acetic acid. What is the formula of acetic acid? Like CH3COOH you are writing now. So now what you can say is CH3COOH you are writing. So now just see how many carbons are there? 2 carbons are there. How many oxygens are there? 2 oxygens are there. How many hydrogens? 4 are there. Okay, like this. So just take the simplest whole number ratio from these. So you'll get C1H2 O. So this is the empirical formula of this acetic acid. See, empirical formula of glucose and acetic acid are seems to be same, but molecular formula is different for these two different compounds right now. So this is the basic difference between empirical formula and molecular formula. So what you can say, chemical molecular formula is a actual represents actual number of atoms present in the given compound, whereas empirical formula is the simplest whole number ratio of all the atoms or elements present in the given chemical formula or the given chemical compound. That's it. Okay, so now what they are saying, so what is the relation between empirical formula and molecular formula? See, if you observe this glucose here and here, so what you are getting from these two observations, see what I have made here, molecular formula equals to, this is molecular formula equals to this empirical formula, this is the empirical formula, no? So empirical formula into 6 times if I do, I will get this molecular formula of glucose. So we will get a whole number like this here. So I am writing that n here, that n represents 6 in the case of glucose. Okay, so you just write molecular formula equals to empirical formula into n. So n represents a whole number like 1, 2, 3, 4 like that you can take. Okay, right. So like n can be only 1, 2, 3, 4 like that. Okay, it's a natural number you can take here. Okay, so that's it. So what they are saying, CH2O is a empirical formula of the compound, whereas molecular weight is 90. Okay, so now using this small relation you can calculate this. See, molecular weight is 90, this molecular formula weight is 90, whereas empirical formula weight we need to find. See, 12 carbon means how much its weight? 12. Hydrogen means 2 hydrogens are there, each one is 1, 1, so 2 are there means plus 2. Okay, the next oxygen is atomic number is 8, so molecular atomic weight is 16. So just try to add them. So 14 plus 16, see, 14 means 20, 30, so it will becoming 30 here. So that's it. So molecular formula weight by empirical formula weight will be giving you this n, number n. So what is the formula, molecular formula weight? It is given as 90. Okay, empirical formula weight is 30. So if you cancel out this, you will get a 3. So n value is 3. So n is 3 means the empirical formula, what do we have? CH2ON. So molecular formula becomes as CH2O, empirical formula multiplied with 3. Okay, 3 times. That is nothing but C3H6O3. So this is the formula, this is the molecular formula of the given compound. So just look at here, yes, we got C3H6O3. So everything here that is required for you to understand the concept is clearly mentioned. Just go through these notes once. Okay, download it from our MedWorld app, then you can read it once again so that you will feel more confident and more clear on the discussion. Yes, Lasya, hi dear. Lasya Kandregula. The discussion is clear, whatever we are discussing. Yeah, so look at this, empirical formula is the simplest whole number ratio of elements in the compound, while molecular formula gives actual number of atoms, whole number ratio of elements present in that. So molecular formula equals n into empirical formula. So molecular weight is 90, empirical formula weight is 30. So you take molecular formula weight by empirical formula weight, that gives you 3. Therefore you can get molecular formula equals to empirical formula into n. So our n value is 3. So molecular formula will get as empirical formula into 3. So it becomes C3H6O3. That's it, C3H6O3. That's it, we got the answer, right? Let us move forward with a few more questions here. How many moles of glucose present in 540 grams of glucose? It means you need to calculate number of moles of glucose by taking 540 grams. See, I am giving you for some 540 grams of glucose and asking you how many moles it contains. Okay, so it's very easy. The number of moles formula what we have, see the number of moles will be equals to number of moles of glucose, here you can take as weight of given weight of glucose by molar mass of that glucose. Okay, right. So the given weight of glucose is 540, whereas gram molecular weight, that is molar mass of glucose, is 180 gram per mole. Okay, now you can take weight of glucose as 540 as given in the question by molar mass of glucose as 180 in the denominator. So 540 by 180 is how much? So it will be 18 3s are 54. That's it. You got n equals to 3. So the number of moles of glucose are how many? Here 3 moles of glucose is present. Okay. The next one here is calculate the weight of 0.1 mole of sodium bicarbonate. See, sodium carbonate. So how do you do this? What is the formula of sodium carbonate? See, there are two things. One is carbonate, sodium carbonate. See, carbonate means this unit should be there. This unit should be there. This one. Okay. When I say bicarbonate, it should contain HCO3 minus unit should be there. So what type of compound it is mentioned? Sodium carbonate. So carbonate should have -2 charge. Then sodium will be having +2 charge. That means Na2CO3 is the chemical formula of sodium carbonate. So yeah, so first thing is getting the formula of compound given first of all from the chemical name. Okay, right. So number of moles given as how many? Number of moles I am indicating with 0.1. So just now we have solved number of moles equals to weight, given weight of the substance by molar mass of that substance right now. So now I want this given weight of that substance. Okay, now weight of substance will be equals to number of moles into its molar mass. So number of moles are how many? 0.1 as in the question they have mentioned. Then next here, what is a molar mass? See, for sodium it is 23. For one sodium it is 23. Atomic weight is 1 sodium 23. There are 2 sodiums, so 2 into 23 plus there is 1 carbon, so its weight is 12. Okay, atomic weight is 12, and there is 3 oxygen, so 3 into 16 for each oxygen. That's it. So just calculate this, 46 plus 12 plus 48. Okay, that's it. The total sum will be, you will get 106 here. See, 6 plus 48, so it will be how much? Like you will get 16. This one will be 106. Overall sum will be 106. Just see here, 106. That's it. Okay, that's it. Sorry. Okay. So what we got? Molar mass of substance as, let me give you a minute. Yeah. Molar mass of substance is how much we got? 106 we got right now, 106 gram per mole. Okay, and number of moles are 0.1. The next, what I told you, number of moles equals to weight of that substance by molar mass of that substance. Now weight of that substance will be number of moles into molar mass of that substance, that is 0.1 into, what is the molar mass we have? 106. Okay, that's it. 10.6 grams is the weight of this substance. Weight of this Na2CO3 is 10.6 grams. Okay, so this is how you need to calculate the weights from the given quantity of substance. Okay, is this clear? Right. Then yeah, so the remaining part, that is we need to study about thermodynamics questions. Okay, so we need to study from thermodynamics, states of matter. So all these are there from 2 marks discussion. Okay, yeah, right. So we will be discussing them in the upcoming session. So until that, you just stay connected with our NEET World channel. Okay, and if you have any confusions or any doubts, feel free to express in the chat box. Okay, so thanks for watching. Stay connected with our NEET World channel. And guys, finally, if you are new to this channel, just click on the follow button, and you can also share with your friends who are preparing for IPE exams. Okay, so thanks for watching. Thank you.